Previously on Construction Disruption, we identified our problem.
Things are way too expensive.
We discovered new construction tech.
This is crazy.
And we found clues on how to solve the global housing crisis. Today, we're making a huge decision.
We could spend $1 million on so many other things.
Are we going to spend $1 million on a 3D printer? So far, we've explored AI, SIPs, and 3D printing, all of which can reduce cost, speed up building, and let us build better. But now it's time to put my money where my mouth is and move the needle on doing something about the housing crisis here. In the last episode, we went to France and saw firsthand what the Maxi printer can do. Now, if I'm gonna bring that here, I need to buy one. And these things aren't cheap. Let's see, we're looking at $823,700. There isn't a single Maxi printer in this country. So I've got to figure out how to get one, plus the shipping, and
then we have to figure out how to use it.
And this will be the key to building my 6-story apartment that would normally cost $14 million and take 3 years to build in half the time and half the cost, while still making sure I don't sacrifice on quality. Regular building plans assume lots of separate trades and steps. You pour a slab, then the framers come and they build their walls. After that, you've got an electrician running wires, plumbers cutting holes, insulation going in and drywall on top. It's a long line of trades, all waiting for each other. It's slow, it's expensive, and half the time you're tripping over someone else's work or over someone else's mess because they haven't bothered to clean it up. Every country has its own way of doing it. Different climates means different codes and different materials. In Canada, well, we pack in the insulation to fight the cold. In France, it's lighter blocks and sand mixes. In Kenya, they use a lot of natural stone and concrete. The rules change, but the dance is always the same. One trade after another. Now get this, a regular crew might need 10 people and a few days just to get one wall up. Our Maxi printer does it in hours. 2 people, 1 machine, and you're done. Today, we're going to figure out how to get one of these things here. It turns out though, this is a bit more complicated than just adding one to your cart and getting 2-day prime shipping. First, I had to justify spending close to $1 million on a 3D printer. And that meant convincing my brother, kind Kevin, to hop on board.
What's this gonna cost us?
Well, yeah, it's about $1 million.
You f***ing out of your mind?
Come on, look, let's just hear me out.
Are you unbelievable? Dude, no.
We set it up, we're gonna be able to print anything we want, wherever we want. Not to mention, it's the first one in Canada. It'll be like the coolest thing you can ever think of. So, dude, what do you think? Tell me. Hello? Hello? Oh man. If we're gonna buy this printer, I need to make sure that once we get it here, we're gonna have something to print. And this means we have to adapt our building plans to accommodate this 3D printer. Yes, unfortunately, before you 3D print anything or any building, you have to make sure it's 3D printable. The process of doing that is actually more involved than you'd expect. This step is called optimization. Traditional building plans are flat like a map. A 3D printer needs a 3-dimensional shape. Designers take the flat floor plan into a computer and pull the walls up, turning lines into 3D blocks. This is called CAD to BIM modeling conversion. Let's check this out. On paper, a tiny gap in a line isn't too significant, but to a computer, this gap means the wall is actually broken. This isn't a good thing. The designer has to make sure every digital wall is perfectly solid and sealed tight, or the printer, it gets confused. Next, we're gonna toothpastify our design. This is the most important part. Traditional houses are built with wood, blocks, or other building material. Now, 3D printed houses are built by squeezing out layers of wet concrete, similar to squeezing out toothpaste onto a toothbrush. The design must change to match this method. Robots, well, they kind of hate stopping and starting. So that's why the designer changes the house layout so that the walls flow in one long continuous line as much as possible. Think of it like this. If you try and make a sharp 90-degree turn with the tube of toothpaste, it's gonna get pretty messy. The designers round off the corners so that the robot nozzle can glide around them smoothly. Next, we have to reinforce this wall. Now, a brick wall is solid all the way through. A 3D printed wall is usually hollow. To make it strong but light, the designer creates a zigzag or honeycomb pattern inside the wall. This saves concrete and provides space for insulation. If it isn't obvious by now, you can't just print in thin air. So designers have to optimize the printing schedule so that the layers of concrete can actually bond to each other properly. Next, this is what we like to call the overhang rule. If you have a window, you can't just print concrete across the top of the opening. It will drop and fall. That's where designers get creative, and either they build using a lintel or change the shape of the window so that the concrete builds up gradually, like an arch. Next, there's electrical and plumbing. In a normal house, you can cut a hole in the drywall and later add an outlet. In a printed house, the walls are stone hard. Designers have to leave tunnels in the digital model for wires and pipes. These get converted into conduits on site, which allowed for easy transfer of electrical and plumbing after the walls have been printed. Once the 3D model looks perfect, it goes through a final translation called slicing. Imagine taking a loaf of bread and slicing it horizontally. The software takes the digital house and slices it horizontally into thousands of thin layers. The computer looks at each slice and draws a map for the robot. It tells the robot, start here, move this fast, squeeze this much concrete, then move up and do it again. Let's be honest, most construction companies, well, they don't have $1 million just sitting around in their back pocket. That's where Printera, our Canadian 3D printing partner, stepped in. They helped line up the bridge loan through lending firm and backed by our bank and made sure the deal actually happened. Now, things got a little complicated, as they always do when you're wiring large amounts of money across borders. But thankfully, Printera helped us pull it all together and bring the first Maxi printer in Canada home. Then there's shipping. The Maxi printer ships in its own shipping container, and because it's on a major commercial waterway, Le Bruxelles-Liscaux, it got to Canada much quicker than if it had to cross the continent. Of course, with many things passing the border, there were delays. So it ended up taking 6 weeks to get to our country. But because customs didn't know what it was, it sat on our docks for an extra 3 weeks before they let it leave. Finally, after crossing half our continent, it got to us. Welcome to your country, Belle.
Like a kid in a candy store right now. It's like that time when you're waiting when you're a kid and you know you have a present that you get to open for your birthday, but you have to wait till a certain time because you're not allowed to open it until other people come to look at you while you're opening it. That's exactly the way I feel right now. Right.
The reality of what we actually purchased just sank in, and it was mind-blowing because I realized that I had just made Canadian history by buying the first mobile 3D printer in all of Canada. I actually could barely contain myself because I was so excited, and even though I knew what was in there, it was still this moment of like, this is gonna be mine. Opening a shipping container instead of a cardboard box from Amazon is an unbelievable feeling.
It comes with a complete configuration on where everything goes inside the C-can so that anybody that's taking this out can actually put it back together where it's supposed to go. So it's very organized. Good job, Construction 3D. And never seen this before, but I actually have my own little fire suppression system on the door just in case we blow up.
This is the moment that the Maxi printer is going to get its first trial run on Canadian soil.
So she is powered by a little diesel to get her going, but she's extremely efficient.
So they grabbed a hold of it and got it to work. But then it was my turn. And the first thing I did was I grabbed it, did donuts right in the middle of the platform.
Donuts on this surface is a good surface. Donuts on concrete, not recommended because it'll chew up your tracks quicker.
Now wait until we unfurl this you're going to see the true potential of what this machine's going to have to offer. It may look like a little baby now, but when this thing pops open, it's going to look like a giant scorpion. I can't wait to look at it.
Although the Maxi printer came operational out of the box, it still needed assembly to be ready to print. There were a ton of parts that we needed to unload, and some, they were unexpected.
Some paint for any touch-ups on the actual printer. So this is an extremely valuable piece of equipment. I know we're going to run into some issues with that. It's a pressure sensor for the temperature control of the product that's going to be excruciated out of the end of the nozzle, so you can maintain the temperature of the product as it's being dispersed, and pressure as well.
So
a stator. And what is this too?
So basically, this goes inside. And what this does is that the material comes through here. And then this pumps the material, the dry material, right?
It's a piece for the pump.
So every 300 hours, this part has to be replaced. These are balls that I'm assuming go through to clean. So these are your cleaning balls. So these get fed through inside the hose to clean the inside to take the concrete out so there's no waste.
And this list goes on, even including tools.
We've gotten our Maxi printer out. We're moving slowly through each piece now. We're on to the next part. Lee, what is this?
This is going to be the silo, right? So where all the material gets put into that then feeds the pump. So this is the second big ticket item that we're going to be taking out today.
That giant thing there, that's our hopper. And with the help of this big lift, we're able to get it into position and hopefully begin printing. We had to get the rest of the parts out so that we can complete assembly. From computers all the way to counterweights. And once these are installed, we should be in the clear. But then we hit a major snag. The Maxi printer arrived with a 240 volt power cable. And here in North America, we use 120 volt. And without the correct power setup, we couldn't run the Maxi printer at all. It's much more than simply slapping on an adapter on the cable. Remember, when I said Europe uses 240 and here we use 120, even if I could plug it in, we'd still need to double the power to get it going. So they had to swap out the modules and certify that the Maxi printer could actually work. It's stuff like this that you would never think of, that could derail your entire project. But luckily, we were able to solve it. Because this was the first one in Canada. It was the first time this conversion happened here. Thankfully, it worked out. The Maxi printer came to life and we were able to do this. Print the first ever made in print from a Maxi printer in Canada. And I gotta tell you, Papa was proud and Belle performed.
That is the first line ever out of the Maxi printer ever poured on Canadian soil. Pretty cool. Wow.
Kind Kevin would be proud to know that I didn't blow nearly $1 million. Finally, it looked like we were gonna be able to print our 6-story building. So we thought. So the first problems have already started. I'm gonna have to go find another property. That's ridiculous. I'm telling you right now, we're sticking to this plan and we're not gonna deviate it. In the next episode, we find out what happens when innovation meets regulations. Zoning. You're gonna wanna stick around because it gets deep. And if you haven't yet, smash that subscribe button and we'll catch you on the next one. Yeah. That was pretty good. To sum it all up, it's flexible. It's smart, she works hard, she's got long legs, she's got a big neck, she looks cool as hell, kind of scorpion-like. Maybe, maybe not, she could kill you. I don't know. Robots taking over the world, we don't know. But in the end of the day, why it matters is because we've got less waste, less labor, less times. She delivering equals more homes.